Hello and welcome. This is my first video in quite a while, and my first in particular since the Excel World Championships and the Active Cell Conference in Las Vegas, which was about a week ago. Um, and that's mostly because I was very busy in Vegas and then quite spun out and also quite busy with work after getting back home. Um, so I could wax effusive about it for a much longer time, but I'm just going to start by saying Vegas was awesome. So many interesting people, so many people that I, rarely get to see, so many people I met in person for the first time or just met for the first time, period. But a lot of them seemed to be people I knew from the internet. I was like, oh, look, you have a body. That was very nice. Um, I just took stock. I realized, with the pace of the rounds for the last while, that I definitely wasn't keeping up. And then obviously we got a whole lot of new cases in Vegas. So all told, I think there are like 16 cases from the MECC and MEWC uh, just from like the last couple of months that I have not posted videos on. But about a half dozen of those I tested. Like I did all the MECC ones and the last chance qualification round I was not taking part in, so I tested those, and I have recordings of my live solves. And I was going to put those up, but then I thought, I wanted my first post-Vegas video to be a post-Vegas recording. So the only one that I haven't actually done is this case called IsometriChaos by Klinsmann Langhanz. And obviously, I watched the semifinal, so I do have a pretty good idea what this is about. Um, and this is one of the cases where, people got to read the general instructions for a good kind of 20 plus minutes beforehand. So, people going into it had an idea what it was about as well, but obviously I've had a lot more time to think about it than they did. So the idea is that we're looking at an isometric grid. And Klinsmann specifically said he wanted everybody to be like tilting their heads, and there's some great shots of various people, especially Jean Woolley got particularly caught. There was just a moment of like, but there were lots of great moments like that. Anyway, so the idea of the ISO grid is that the grid is turned 45 degrees. So we've got our ISO references that are like A1 here, then B1, C1, D1, A2, B2, C2, D2, etc. And then that leaves a bunch of empty spaces because there's nothing, there's no ISO ref in any of these yellow cells, and so those are just populated with numbers, which I guess we'll ask questions about. So I have a sort of loose sense of the shape of the case. I don't actually couldn't kind of squint enough at anybody's screen to see what the individual questions were, although I have a sense from some of the visuals that were on screens of what it's going to look like. So I'm trying to be, semi-Vegas style. So I've blanked out the score here and I've hidden the score feedback, but I do have the score in the format that we get to look at it there. So, I'll see my current score and how much of the levels I've got out, and whoops, don't want to move that, and how many of the bonuses I've got as I go along. And obviously I'm going to try and play it somewhat game style, so, anyone could get the first bonus, 10 players could get the second bonus, 8 players could get the third. So there wasn't, like last year this was kind of 5, 4, 3, 2, 1 out of 8 players. So there was a lot of time pressure. Here, I don't think anyone got locked out of bonuses, or actually, no, sorry, I remember Andrew did get locked out of some bonuses because he had a rough start to this case because I think he was sitting at the computer Benny Weber had been using in the round before, so it was set to Austrian settings, which meant every time he tried to type something like an XLOOKUP, A1, he'd go to type a comma, except it would see that as a semicolon. It would be an invalid, then he'd, an invalid delimiter, and then he'd go to click on the next thing, and it would give him this kind of pop-up. And then at some point, uh, we in the crowd realized what was going on and yelled semicolon at him enough times, and he figured it out and recovered ridiculously well, certainly with more composure than I would have. But anyway. All right, so having said that, let's get started. I'm going to start with the bonuses just for fun. What is the cell ref of the only empty cell within the ISO grid? Oh, okay. Um, that's a tricky one because my usual approach empties things out. So, I don't know, let's say to call, well, first let's give this thing a name. So we'll call this MP, and then let's do to call of MP, and let's do to call of addresses. I'm sorry, I gotta import my lambdas, Now I got my lambdas, so we'll do toCal of addresses of MP, and then we'll do toCal of row column of, actually let's just do toCal of rows of MP, sorry, not rows, row, and toCal of column of MP. And then I guess there's got to be a faster way to find this thing. Ah, I know what I want. I know what I want. I think. Let's do search by format. Format. Oops, sorry. Format. Find format from cell. That format. Then I want to find all. Select all. Oops, sorry. Oh, damn it, I lost it. Okay, find all. Select all. Why is it not selecting all when I do that? That's, oh, there we go. Now it's selecting all. Okay, good. Just took a second. Then Control G, Alt S, K for blanks. There it is. K33. Okay. All right, so I didn't exactly cover myself in glory there, but I got it eventually. How many 7s are in the yellow cells? And I think that's just countifs MP7. That was easier than the other one, if I'm right, and I am. What's the sum of the yellow cells? Well, I think all the others are text, so again, I think we can just say sum of MP. Yes, okay. Removing all letters and transforming the ISO grid into numbers only. K22 turns to 22, G9 turns to 9, W, blah, 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 blah. What's the sum of all original numbers plus letter removed numbers? Okay. So I'm going to say sum of text after MP, and I have a thing called let's ucase times 1. I'm going to say if error, all that stuff is 0. So that should give me the numbers after the thing, and then add that for the actual numbers, and we're good. Okay, and based on level 5 rules, okay, so I probably can't do this yet. Fine. Okay, what's the content? Okay, so I laid this out with all the gaps in it because I was trying to figure out the blank one, and then I realized that was a terrible way to do the blank one. But I've got a nice thing for this, so I'm going to the map. I don't care about going by call. I don't care about a start. I don't care about a distance function, and I do want to include headers. So now I've got my items, my addresses, and my RC refs. And I'm going to copy value paste that because I actually want to make this into a table because it'll be easier to work with it later. And I'll call that, I don't know, I'll call it T because I always call tables T. And then I also want to add my row, my call, which I'm going to do RC ref to row of that, and then the same thing to call of that. And then I'm going to want my ISO row and my ISO call. Well, yeah, might as well do it while I'm at it. So the idea here is, if you think about, this line here, think about sort of equation of a line. Every time you take a step on it, you're reducing your row number by 1 and increasing your column number by 1, which means that the sum of your row and column number is constant. And that is the ISO row. So my ISO row is just going to be my row plus my column. And similarly for my ISO column, when I go like this, I'm changing my, I'm increasing my row number by 1 and my column number by 1 when I take a step along here. So I can think about my ISO column as my row minus my column. Anyway, okay, so I've got enough set up now. What is the content of the given cell ref? So the content of AA2 in the ISO grid is A1, AA2. Okay, fine. So we're just going by regular reference. So this can be, I think this can just be add to ref of this in MP. Just check. Yes, good. Okay, next level. What's the cell ref of the given ISO ref? So here we'll XLOOKUP in T. Sorry, I should change these names. So this is ISO ref, and this is address. So we want to XLOOKUP the ISO ref in T ISO ref, returning from T address. there. Good, that checks out. And that's that level. Okay, next level. What's the content on the end cell after taking a number of steps in the given direction starting from the given isoref? Remember that the given direction matches the iso grid instead of the regular grid. Instead of the regular Excel one, rotate your head to the right and you'll understand. Okay, so I guess I didn't really mention at the setup. My aim with this video, just because I think this is a really cool, interesting case, and I think there's a lot that you can do with it. So I'm not particularly aiming to kind of do a half-hour solve. I don't particularly care if I do or not because I'm not competing, and because I've had way more time to mull about this than the competitors did. But I do want to think about what are some interesting ways that you could think about approaching this. So let's start with like there were a few cases in the finals where it seems to me like maybe a goal, or a partial goal at least, was to try to make things a little bit more lambda proof, because lots of people have lambdas that say, you know, from this address take this many steps in this direction, but now the directions are getting rotated, and that's going to make things a little bit confusing. So what are some ways you could deal with that? Well, one is I've still got my list of arrows, and this case, at least, unlike Harry's, did use that list of arrows. Now, this one, I've got it laid out as left, then right, up, then down, because, you know, sometimes you're interested in just the 4 cardinal directions, sometimes you're interested in the whole list. I think if I say sort of that, yeah, that then puts them in is that clockwise? Yes, that's clockwise order. That's what I thought. But before I do that, so I've got my arrows, and then I've also got another named range, which is our offset codes. So I think I've talked about this before, but you know, all my map functions rely on kind of translating everything into a common language. So for example, I can get a row col num from this range, which will be cell N94, and that will be 94 million, meaning row 94, and 14, meaning column 14, which is N is the 14th letter. And I can also get, you know, I can do arrow to RC ref of an arrow, and it translates it into an offset. So in other words, going up and to the right is reducing your row number by 1, which is minus a million in my language, and increasing your column number by 1, which is plus 1. So you get minus a million plus 1, which is minus 99999. And I can translate text into row column references and so on. And the whole idea is that you get everything into like locations and offsets, and then you can just add them together like numbers. And then I have various functions for going back. So if I say, let's say add to RCRef, that's that. Then I can say, well, that's not a great example, but anyway, if I want what is F6 over here, let's just put something in for a second so I can see it's working. Then I can say add to ref, address to reference of this number and the map. And have I forgotten? Oh, sorry, this isn't an address to her. This is an RC ref that I'm starting with. So different function RC ref to ref. So change an RC reference code into an actual reference to a cell, which gives me that X, or if I change that to whatever, a P, then that's pulling that through. So it's just, there's a whole kind of setup here of things that allow me to kind of translate it into these row column codes that are easy to work with, easy to add, subtract, blah, 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 and then translate back from those. So once I have that set up, I can take this whole table and sort it so that I have it in kind of clockwise order, and then I just need to kind of visually check. So basically, because I'm rotating everything by 45 degrees, once I have them in clockwise order, I'm just going to need to offset them in one direction or another. So let's just check. My up and to the left arrow, which is here, that should be treated as an up, which is this one. So I think that means I'm going to need to shift all of these up and put that one to the bottom. And let's just check. My up and to the right arrow is now, let's see, my up and to the right from here is just one step to the right, which is moving along a column, because this is up and this is right in the ISO grid. So then my up and to the right is just going from that 1 to that D3, or this C3 to this yellow cell next to it. And then I can basically carry on. So I'll call this R's and call this R off, which is similar to the names I have elsewhere, but not exactly the same, which is good enough. So now we just need to say what is there. So I can use the rest the same as before. So I can do add to RCRef to convert that, plus this times xlookup, this in R, R's returning from R off. That gives me the reference, and then I want RCRef to ref of that reference on map. And that's giving me an X, which is saying it's out of bounds. So that's not good. 1003. What? Oh, sorry. This is my isoref. Okay, so hang on. First I have to convert this. So I'll xlookup this in T isoref, returning from T address. So I'm actually starting in cell AA6. So let's grab that and put that in here. And now we should be able to RCRef to ref. Oh, sorry. I got to say where I'm referring to it, and that's on map. And that is F7. Okay, good. So then use my robot command to just paste the formula in there. And let's see. Yes, that's that level. I want to say I had another way to think about it. Oh, yeah, I did have another way to think about this. So this was kind of starting from my existing arrow setup and changing it, but here's another way to think about it. Let's just say we did unique of these. Oops, these. Oh, right, because we only have diagonal arrows. Well, that actually simplifies things quite a bit, doesn't it? Maybe we're going to have, yeah, we're going to do something different with vertical and horizontal. Okay, well, might have overcomplicated that, but never mind. Anyway, the other way that I was going to suggest thinking about is if you got your list of arrows, you could think about it as like you've got an origin here. So if you go up, ISO speaking, that will take you to here, up and to the right. If you go up and to the right, ISO speaking, that'll take you to here, and you can, oops, sorry, I meant to cut that, and you can keep going around. So this one, oops, cut, paste, down and to the right will be actually down, yes. Straight down will be this. Copy instead of cut again. So you can see you've got this sort of swirl pattern going on here. And then you can say, okay, well, up is minus, I've actually got a constant here, minus underscore m, 0 and underscore m, sorry, equals underscore m. And then that's the column offset, and sorry, that's the row offset, and then the column offset is just 0 minus 1, 0. So then you can just add this and this, and then you can say, okay, so this this left arrow matches up to, you know, the left arrow isometric reference is actually up and to the left, and that corresponds to this offset, and then you can just flatten, flatten both of those, and you get this same kind of lookup table, but from first principles. So just, you know, lots of different ways you could think about that. Having a sort of flexible common language of, you know, row times a million plus column. My code is actually a little bit different from that. It's let's do add to RCRef. It's row times a million plus 1,000 plus column. That just means that the formula for extracting the row number, sorry, the column number, doesn't have to change if the column number goes negative. So if the column number goes negative, you can't be referring to an actual cell, but you could be referring to, you know, a journey that goes outside the grid and comes back in. And you know, if let's say you went 15 columns to the left there, then you've got 999. So the idea is you can still say mod of that by your big number, which is m, the 1 million, and you get 999, and then you subtract off 1,000, and it leaves you with a -1, as opposed to if you took out the 1,000, and then you said this minus 15, and then you said mod this by a million, you'd end up with this enormous number as opposed to -1, which just is a little clunkier to work with. Anyway, that's a lot of waffle, but that's level 3. Let's go on to level 4. Now we have to track the numbers through the whole path. Depending on the starting cell ref, which will always be a number in the grid, we must sum all the numbers in the given direction, horizontal or vertical. Okay, so with the setup I've already made, this is actually super easy because we're looking at things that are on the same ISO row or the same ISO column. So, this is going to mean ISO row and this is going to mean ISO column. I think all we would need to say is we'll sum ifs. Sorry, I think we're summing. Hang on. Sum all the numbers in the given direction. Yes. I'm just wondering if any of these are. Well, let's look them up and see. So, sorry, I'm wondering if any of these are, for example, a B4 as opposed to a 5. Like if they're an orange cell, then the row or the column would only contain cell references, and then I'm wondering, do we need to convert them to numbers? So let's just XLOOKUP all of these in T isoref. Is the isoref I'm looking at, isn't it? Z6. Oh, no, it's actually not the isoref, sorry. It's the address returning from T isoref. And those are all numbers. Okay, good. So we don't have to worry about that. No trickery at work here. So I'm going to XLOOKUP this in T address returning from, I'm going to say if this equals this lock. So in that case, I'm going left to right, which means I'm interested in the same ISO row. So then I want to return from ISO row. Otherwise, I want to return from T ISO column. That's it. So this tells me Z6 is ISO row 32. So let's go Z6. So that makes sense because you're in 26 plus 6. Yep. No, 26. Anyway, I don't know, whatever. No, that doesn't seem right. Let's go find Z6. So the ISO row is the one where you add them up. But if you add them up, I think I've mislabeled my rows and columns. If they add up to a constant, that's the column. Okay, so I'm just going to name this. I think this is ISO col and this is ISO row. Let's just see. If I pick some column 33, my address is AC4AB5. AC4 is there and AB5 is there. That is in fact a column. And now what did I? Yeah, okay, fine. So that's done that right. Okay, so now I need to fix this. So this is supposed to point to row and this is supposed to point to column. So that's that, and then I want to sum ifs. I called it isoref, but it's the same column that contains both the ISO references and the numbers, where T, where this whole thing is this XLOOKUP. I think that's what I need, 130, yes, looking good. And sure enough, that checks out. So that's one way to do it. But again, different options here. What's going on with my Excel? Don't know. It's getting grouchy. I'm going to pause and give it a kick. Okay, not sure what happened there, but we're back. So I was saying that, so this is one way to do it, which is to say, build the ISO column and the ISO row and figure it out that way. The other way is to think about your row and column offsets from wherever the heck we put our arrows. Where did we? Here we are. From here. So you can basically say, well, this left-right thing means that you're going as far as you want in either this right direction, which is plus 1,000,001, or this left direction, which is minus 1,000,001. So you can say, so I need to convert this cell ref to an RC ref, and that is a cell ref, not an ISO ref. And then let's see, the furthest, I think it said it's a 26 by 26 grid, so the furthest you can go in any direction is 26. So then I could say if this equals this, so again, in the case that we're looking at rows, then my magic number is this thing. Otherwise, I'm interested in the up-down, which is this thing. And then I'm going to lock both of those. Oops. Copy that, and then I'm going to say this times sequence of, let's say, 53 numbers starting from -26. And that's going to give me all the offsets in that direction from, from sort of 26 rows to the left to 26 rows to the right, or the equivalent for up and down. So I'm going to say that plus this. That's going to give me all the addresses, and then I'm going to say rcref to ref to convert all of those back into. Oh, you didn't like that? Oh, sorry. Yes, because I have to put the second argument, which is MP. So then these x's are out of bounds, and then these. Oops, move over. There's some. Where are there zeros? Oh, sorry. Yeah. So this is. So there's out of bounds meaning totally off the grid, and then there's out of bounds meaning here where it's just returning 0, and then eventually we get to some numbers, and hopefully those numbers will add up to 130. But let's just put it all in one place. Where are we going? This. Where that goes, and then we can. I'll actually use my nice little robot command, wrap with sum. 130. So we'll put that there, and yeah. So that's just another totally different way to do it. All right, let's look at level 5, which will also let us do the bonus. And we got level 4. Okay, same as level 4, but now we'll start only on iso-ref cells instead of number cells. Okay, fine. As we're not starting in number cells, we must sum the two adjacent sides in the given direction. Okay. So this is pretty easy, I think. So this one, I think we could copy down. And I just need to think for a second about how you do the offset. So if you're looking at columns, then you'd need the one that's one smaller and the one that's one. Yeah, this is. I don't want to jinx it, but I think this is going to be an almost direct copy over from here. So that'll give 0 because what that's doing is summing the column containing C7, which has no numbers in it. So we just need. So the condition is, so we're saying sum the isoref, which is like the contents, so that's isorefs, but also numbers for the yellow cells, where this column, which is one of the two things, is this value, and then I think we just need to say plus -1, comma 1, and that'll give two values, and then we need to sum them up. And if that gives 210 first time, I'll feel pretty happy about myself. It doesn't. So let's just take a quick look at C7 over here. Isoref C7. And what do I have? I probably don't have the right things around that. So let's see, what do I actually want? C7 should be next to. No, this isn't going to do it. Let's Control F C7. Sorry, get rid of the preview text. There it is. So I'm looking at address V10 and address X10. So sorry, I want V, W, and X all 10. So let's grab V10, W10, X10. Oops, X10. Okay. So columns are shifting by 1. The ISO columns are shifting by 1, and the ISO rows are shifting by 1. Okay, so let's just slow down a little. So we're going to sum that where we're interested in isogrid BH, which is isocol. Good. I'm sorry, that's yes, fine. And then we're going to look up C7. and find the isocol of that, which is giving Na. What? Oh, sorry. I see it now. I see it now. There is another difference. We're looking at cell refs here, and we're looking at isorefs here. So I just need to change this. You're not looking up in the address, you're looking up in the isoref, and that does give the 210, and then gets the rest of the level out. Okay, so a little more nuance to that one, but not a whole lot. And then this one, I think, will work quite similarly. So we need to do that thing again. So instead of doing the address to, oh, sorry, well, first things first, instead of, okay, now copied it, so it'll update the references. So instead of doing an address to ref here, I'm going to do an XLOOKUP of this isoref. I'm going to look in tisoref, returning from t or cref. That's the first piece, and then so this, let me just pull this piece out for a sec. What? Oh, sorry. It keeps auto-correcting that. What's going on here? If that, otherwise that, time sequence of that. Okay. Sorry. I'm doing my RC ref to ref wrong again. Okay, so that's my thing, and then I want to do that plus -1, 1. So that's going to be the offsets to the left and to the right. And I think that's it. If I do that, yeah, that's my 210 again, and those answers all match. Okay, so yeah, I guess either one of those approaches converts reasonably neatly over to level 5. All right, let's get to level 6. Here we have to sum all numbers within the max distance included from the given isoref. The distance should be measured as the next immediate square around the given isoref. As an example, in the first image we have the isogrid, and in the second image we have the distances. Right? Okay. So in example 6, we start from isoref D4, yes, and should sum all numbers within a distance of 3 or less. So wait, are we? Each distance unit is a square layer. Oh, okay. So we're doing, so this is like 1, and this is, the orange layer is then 2, and then the green layer is 3. Okay. That's a little confusing, but okay. So 1, 2, 3. Okay, so I think I can see a couple of ways to do this again. So the first one is we can think of in terms of isorows and isocols. So we're going to XLOOKUP this in T isoref, returning from T, I want to grab 2 columns, isocol and isorow. Sorry, move this up here. So we're in, this is isocol and isorow. So then I think what I want is some ifs T isoref, because remember isoref is the one that contains these references but also the numbers, where T isocol is, so it's going to need to be greater than or equal to this isocol minus the distance, and it's going to need to be less than or equal to this isocol plus the distance. And then we're going to need to do the same thing for isorows. So there's space over here so it lines up. T isorow has to be greater, in quotes, greater than or equal to this isorow number minus the max distance. And then same thing again, less than or equal to this isorow number plus the max distance. 75, looking good. Ah, okay, sorry. That's what it meant about the second image. There's a second image down here showing the distances. That makes sense. Cool. So then let's take these. put them in, and sure enough, that's level 6. But then, again, let's look at a different way to do this. Actually, you know what? It won't work as well for the big. We could. Yeah, the bigger ones are trickier for this method, but you could. So, okay. So the other thing I was thinking of is you could do. What's the easiest way to do this? Let's see. The biggest ISO distance, sorry, the biggest distance is 13, which means we would need a 27 by 27. So let's just first do sequence 27 starting from minus 13 in step. Yeah, that's fine. It's fine. And then plus sequence of 27 across. So now we've got. I think I want to wrap each of these in abs. So this is telling me how many rows and columns away from the center I am, which if I've got, so yeah, okay, so there's my 0, and there's a 1, and there's a 2, and there's a 3, and there's a 4, and that's all basically fine. So then what I want to do is row column of this minus row column of the center is going to give me all the offsets. And then I'm interested in if this number is less than or equal to some distance, let's call it 3, then I'm interested in these offsets. Otherwise, I'm interested in NA. So that'll give me a bunch of NAs and then the relevant offsets here. And then I can call all of that with 3 to ignore errors. So these are all the offsets that will take me within that kind of square of ISO distance 3, that shape here. Now this doesn't scale as well because you need a blob of 27 by 27, knowing that the maximum distance is 13, but it's an option. So then once you have that piece, then you should be able to do something pretty similar to some of the approaches before. So let's just take a quick look. So those are all the offsets. The starting point is the ISOREF, so we want to convert the ISOREF into an RC ref. So we're going to XLOOKUP that in T ISOREF. Get out from behind the camera. T ISOREF, returning from T RC ref. So that's the sort of location of that cell, and then we want to add all of these to that. And then we want to, yeah, I think then we can just RC ref to ref all of that stuff on MP and sum. And that, sure enough, gives 75 as well. And breaks immediately when I copy it down. Sorry, because I didn't lock these references. So lock that and lock this. And yeah, that seems to agree. So that's, again, I think the more elegant solution for these is the one that kind of builds off the table and just uses ISO calls and ISO rows. But you can see there's, with this kind of row column offset idea, it's easy enough to build sort of a line. It's easy enough to build a box, that kind of thing. I think that breaks down, if I remember the last level right, but never mind. It got you pretty far. All right, so last level, before we do last level very hard, let's do the bonus based on level 5. Based on level 5 rules and all ISO ref and direction combinations, what's the max possible sum for a particular ISO ref? Okay, so mostly we just want to group by the columns and the rows, but we only want to do it for ones that have ISO refs, which I think corresponds to odd rows and columns. So let's do this. We'll do group by. So my fields are going to be, sorry, my row fields are going to be this. Values are going to be that. And some error. What? That's unexpected. What? Have I got them the wrong way around? No, I have them the right way around. What on earth? Okay, never mind. Let's do unique of isocol. And then let's do let A be that, and I want to filter A where is odd A. And that means I'm only looking at the ones that are for actual isorefs, and then I want to sum ifs this where this is this. Sorry. Wait. Level 5 rules. Oh, sorry. Level 5 rules. We're looking at the 2 on either side of it. I remember now. So plus -1, comma 1. And then we'll do a by row sum. Okay. And then we want to do the same thing for the ISO rows. It's probably a nice simple data table approach for this as well, but never mind. And then this has to become ISO row. And then we just want the max of those two, which is this and this. And that's 285. And let's see if that's the answer. It is. Hooray. Okay, so then level 7. I'm conscious I've gone long, but on the other hand, I'm not that worried because I think this was more about an educational video than a speedrun video, so whatever. Last task is to sum the numbers in the quadrants formed from the given isoref and diagonal. Remember that the given direction matches the iso grid instead of the regular Excel one. Fine. In example 7, we start at isoref C4 and have to sum all the numbers from the top left and bottom right quadrants in the iso grid perspective. Oh, got it. So this is top left and bottom right, and this is the other way around. Fine. So basically we're saying if we're looking at these two, then we want the ISO row to be lower and the ISO column to be lower, or the ISO row to be higher and the ISO column to be higher. Otherwise, we want one to be true and the other not to be true. So I think that we can do this. So first, let's do XLOOKUP this in T isoref, returning from, and again, I'm going to return both the isocol and the ISO row. This is isocol, this is ISO row. And then we're going to say what are we going to say? We're going to say, so I want to compare T isocol to this isocol, and I want to take the sign of that. So this is going to be -1 if we're in a, which way around did I do it? I did column minus that one. So it's the equivalent to saying subtract off 248. So yeah, so if we're above it, it'll be negative. If we're below it, it'll be positive. And if we're on the same, it'll be 0, which I think is what I want. And then we'll do the same thing here, but with ISO row. And then I want to say this times this. So anything where it's on the same column or the same row is irrelevant because it's not going to be a number because we're going for an isoref. So if they're both less than or both greater than, it's going to be 1. If they're both, if they're opposites, it's going to be -1. So if we're doing this one, so we'll do that equals if this is equal to this different funky one, then we want it to be 1. Otherwise, we want it to be -1. that's true, and then we're going to do sum of if this, then t isoref, because again, that's the one that also has the numbers. Hey, look at that. It's 2532. Beautiful. Okay, so then we'll just take these in here. That was K251. Perfect. And this one in here, just because then I don't, once it's not spilling out of the row, I can, where? KL. Boom. Hooray. Okay. I can't immediately think of, I mean, I can think of the equivalent to the above methods to do this one, which is you could, add up every offset in this direction and every offset in this direction to get the set of all possible offsets. I mean, the map is only 26 by 26, so you at most need a 26 by 26 for below, a 26 by 26 for above, to the left, to the right. But it's definitely less elegant at that stage than doing it based on the ISO rows and ISO columns. Yeah, anyway, like I said, I'm conscious that this video ran long, but I felt like this case deserved a good exploration because I think it's a really cool idea. I think it's got all sorts of like interesting mathematical depths. So I know not everybody likes 40-minute YouTube videos. No, sorry, I only started my timer when I started solving. It's probably more like 50-minute YouTube video by now. But I like depth more than the average YouTuber's attention span. And I like, making stuff that is fun for me more than I like maximizing the size of my channel, which you probably already know if you watch my channel. So I guess you probably don't mind that much. Anyway, that's all I got for today. I'm going to try and tackle the other semi-final, the Temple of the Golden Idol, next. And then the final, hopefully not too much after that. But that's all I got for today. Thanks for watching. See you next time.